Using Visio to create an entity relationship diagram. Here we have displayed some functional dependencies, and we have the resultant entities based upon these functional dependencies. Let's quickly go over them. The department number determines the name and the location. The employee number determines first name, last name, street, city, state, zip, wage, rate, social security number, department number. The position ID determines the position title. The position ID and employee number in combination determine the start date and the end date. We have now taken these functional dependencies and described them as entities using DBDL. As you can see, the first functional dependency describes the department, and the primary key is the department number, which is the determinant. The second entity describes the employee. The primary key is the employee number, which is the determinant. The third entity describes the position. The primary key is the position ID, which is also the determinant. The last entity describes the employee and the positions that they've held, so we're going to call that employee position, and the primary key is a combination of position ID and employee number, which is also the determinant in that functional dependency. The employee number has a foreign key, which is the department number, and that department number references the department number in the department table. The employee position also has foreign keys. The position ID references the position ID in the position table, and the employee number references the employee number in the employee table. When we are finished converting this set of functional dependencies to a Visio diagram, it will look very similar to this. It will have business rules, it will have our 4 entities listed, it will show the relationships, it will show all of the characteristics about each of the columns in each entity. It will also show what is known as cardinality, whether or not relationships are one-to-many relationships have to have 0, 1, or more matching records. So let's begin. We're going to open Visio by doing Start, Programs, going to the Microsoft Office area and clicking Microsoft Visio. Okay. From the Templates category area, we will select the Software and Database template, and we will use the Database Model Diagram template, and we need to make sure it says US Units, and click Create. When the grid opens up, it's rather small. We want to make this a little bit larger, so we're going to go to the View tab under the Zoom group and select Page Width. Over on the side we have our Shapes toolbar, which we will be using in order to pull shapes over as we need them. The next thing that we need to do is set the database display option so that it knows the type of diagram we want to build and what we want to see in the diagram. From the Database tab, you're going to select Display Options. There are 3 tabs here we need to set some options on. So first we're going to go to the General tab and tell it that we want that IDEF1X diagram, because right now it's sitting on a relational diagram. Then we're going to say Default Save As, so we don't have to keep doing that every time we do a diagram. We're going to go to the Tables tab, and we're going to make sure that optionality is set to show as parentheses with an O in it, which it is, so we're just going to say Default Save As, and then we're going to go to the Relationships tab, and we want to make sure that the cardinality will show, and we'll say Default Save As, and we'll click the OK button. So now we've set our database display options. ER diagrams reflect the business rule of an organization, so let's go over the business rules again. Number 1, this company can have many departments. Number 2, an employee can only be assigned to one department at a time. Number 3, upon hire, an employee must be assigned to a department and a position. Number 4, a department must have at least one employee. The company is not interested in tracking past departments to which an employee has been assigned, only the current department. Number 5, the company wants to track all positions an employee has held, including the dates. So, the first thing we're going to do is we're now going to go back, and since we know we need to have these 4 entities, we're going to begin to draw these entities on and include in the primary key and the other columns, and then relate the entities that need to be related, which means the ones that have the foreign keys in them obviously need to be related. Alright, to draw on an entity, you grab the entity shape and you drag it on to the diagram. Down in the database properties area, you'll see there are several categories over here to the left. We want the definition one because the definition one will allow us to give this entity a name. So we're going to click under physical name and we're going to call this entity department. Now we need to put the columns in for this department. So under categories, we're going to select columns. There are 3 columns in this entity, but before we do that, we need to expand this property area up. So there's a line here that has 2 arrows on it. If we drag this up, this will allow us to expand this up so we have room. The other thing, since we're going to be doing an access database, we want to make sure that physical data type is set for access. So now we will go to the first column and type in the primary key, and the primary key is the department number. And we're going to check off primary key, and it'll automatically make that a required column. If you notice in the diagram, it has now added the department number as the foreign key. We're going to move on and add in the other 2 entities. Name, I'm just hitting the enter key to go down to the next row to add in the next column in the entity. You notice on the diagram that when we added in name and location, it has an O in parentheses. That means that entering data into these columns right now is optional. Eventually we would need to go back and fix that. Obviously it's not optional, but for right now all we want to do is just build the entities. So we're going to save the diagram. And if you notice, the file extension is VSD. So now in the title bar we see the name that we've given. Okay. The next thing we want to do is add on the next entity. If we go back to our functional dependencies, the next one is employee number, and we want to call it employee, and the primary key is going to be employee number. We're not going to add in the department number foreign key because when we relate the 2 tables together, Visio will automatically put that in for us. So we're going to drag the entity over again. Go to the definition area under category, and we're going to call this employee. We're going to go to the columns area and begin to enter in the columns, the first one being the employee number, which is also the primary key. So we want to make sure we check off primary key so it automatically makes that required, and then we're just going to enter in the rest of the entities. I'm hitting the enter key to get down to the next row. If you look at the diagram now, we have all of the columns included in the entity. Now the next thing we need to do is to do the relationships between the entities. Before I do that, however, I want to point out something that's important. Right now I have the employee entity selected, and you're able to see all of the properties. If I unselect that employee entity, the properties go away. Select it, you see it. Unselect, you don't. Okay, so now we're going to relate them. There is a one-to-many relationship between department and employees. One department may be assigned to many employees. Therefore, the department represents the one side of the relationship and the employee represents the many side of the relationship. So I'm clicking the relationship shape, I'm bringing it over. The one side is the side without the dot. I'm putting that right in the center to glue that to the department entity. The red border means it's glued. And then I'm going to drag the many side over to the employee table. The red border means that's glued. Okay. As you examine this resulting diagram, notice that there are two red squares at the margins of that line. That means that the line is selected. Once I unselect it, you don't see that. Visio Professional also added the department number in the employee table as a foreign key. That's what that FK stands for. Notice there is a diamond next to the one side, the department entity of the relationship. This diamond indicates that a value in the department number column is not required in the employee entity. This violates referential integrity. A foreign key should not contain a null value. It should contain a value that matches the common column in the one side of the relationship. So in other words, the value in the department number column in the employee entity must match a department number value in the department entity. Another way to indicate that a value in a column is optional as opposed to required is you see that O inside of the parentheses. We must change this diagram to enforce referential integrity within the relationship, and right now what we immediately need to do is make sure that that department number is not optional, and then later on we're going to make sure that that department number matches the department number in the department table. Also notice that there is a dot on the many side of the relationship. This dot indicates the cardinality. Cardinality is the minimum number of required matching records in a related table. The default cardinality is one-to-many. The default cardinality in a one-to-many relationship is 0 or more. In this instance, the diagram reflects that it is okay for some departments not to have an employee assigned to them. This violates the business rule number 4. It states that each department must have at least one employee assigned to it. And what that really means is that every department number in that department table must have at least one record in the employee table that has that department number in it. So we're going to have to change the cardinality on this relationship from 0 or more to 1 or more. Okay, so first let's fix the department number so that it is not optional, it is required. We're going to select the employee entity and find the department number and put a check mark under required. It's not the primary key, it's just required. And when we do that, the diamond goes away and then the O that was showing optionality is gone. Now, to fix the cardinality has to do with relationships. So we need to select the relationship line, and we're going to click the miscellaneous category, and right now cardinality is set at 0 or more. We're going to change the cardinality and make it 1 or more. When we do that, then a P displays next to the dot on the many side, meaning that there has to be at least one matching record in that employee table for every department that's in the department table. Next, we're going to add on the position entity, which has position ID as the primary key and the position title as the column. I'm going to go to definition and add in the name position. We're going to go to columns and add in the position ID. It is the primary key, and we're adding in position title. The employee entity stores employee demographic information with employee number as the primary key. The position entity stores all the possible positions within the company with a primary key of position ID and a column to store the position title. There is a many-to-many relationship between the employee entity and the position entity. An employee could have multiple positions throughout the years they work for a company, and a position could be held by multiple employees. For example, an administrative assistant position, there could be 20 administrative assistants within an organization. There are no physical lines drawn between entities that have a many-to-many relationship. When there is a many-to-many relationship between two entities, a composite, also known as associative or junction entity, is required to convert this relationship into two one-to-many relationships between the composite entity and each of the entities in the many-to-many relationship. Why is this? This is because a database cannot query on a many-to-many relationship. For example, without a composite entity, a user would not be able to answer the following questions. Let's go back and look at our database design language. The employee position is the composite entity, and as you can see, it has the position ID, the employee number, the start date, and the end date. Because we have this entity, we can now ask the following two questions. Which position has an employee been assigned, and which positions have been assigned to employees? So this type of entity is called a composite or junction entity. Think of this entity as an entity that stores the transactions or the specifics about a many-to-many relationship. So now we're going to draw on this composite entity and we're going to relate it. So I'm going back up to definitions. I'm going to call it employee position. Now, we saw earlier that the primary key in that entity was a combination of the employee number and the position ID. We're not going to type those columns in because when we relate it, it's going to put those columns in. So the only other two columns that we needed was start date and end date. So we're going to enter those in. Okay. Now we're going to build the one-to-many relationships between these two. Just moving these over some so there's room for the lines. Okay. So I'm grabbing the relationship tool and I'm putting the one side on the position and I'm putting the many side on the employee position. I'm grabbing the relationship again, putting the one side on the employee and the many side on the employee position. Okay. Now, I still need to tell it that the primary key in the employee position table is a combination of both the position ID and the employee number. So I'm going to select the employee position entity, and I'm going to check off primary key for position ID employee number. You notice when I did that, a couple of things occurred. The relationship lines became solid, and the edges of the rectangle became rounded. Okay, this is occurring because the primary key in this employee position entity is composed of primary keys from other entities. Okay. Now remember, combined position ID and employee number is the primary key. Separately, they are foreign keys. Okay. The last thing we need to do is to adjust the cardinality on here, because the business rules stated that every employee should be assigned to at least one position. That was business rule 3. It did not say that all the positions in the company had to be filled, so the 0 or more cardinality between position and employee position is okay. So we're just going to select this relationship line and go to the miscellaneous category and change this to 1 or more, so we wound up having a P there as well. Let's save the diagram. Now, using a surrogate key rather than using 2 columns to make a primary key unique. The reason I'm showing you this is because you may come across databases that take this approach. And when you use a surrogate key, what happens is then these lines are no longer solid, they're dashed like the rest of the lines, and then this rounded edges is no longer rectangular. So let's look at this and see what happens. Now let's talk about the surrogate key, and then we'll demonstrate. A surrogate key is a unique value that is automatically generated by the computer. For example, the column would have a data type of auto number in Access, or it would have the data type of counter in most other database management systems. This value is increased by 1 every time a record is added to a table, thus making the value in this column unique for each record. This occurs behind the scenes without the user's knowledge. An artificial key works very similar, except for the customer is aware that that number is being generated, and they use that number when they correspond with a company. For example, your CCBC student ID, which is the number that starts with 9, which you use when you're registering for a class. If we changed the primary key in that employee position entity to use a surrogate key, be it artificial or one that is known or not known, we're going to call it employee position ID. If we do that, then at that point the position ID and the employee number are just foreign keys. They're no longer serving in combination as a primary key, and so the diagram is going to change. So let me quickly do that. I'm going to add a column, and I'm going to call it employee. And I'm going to make that the primary key, and I'm going to remove position ID and employee number. And as you can see, it has now changed the diagram. Okay. I'm going to close this without saving and open it back up so I can go back to my original diagram. entering column data types, sizes, and required columns versus optional entry columns. First, we need to change one of our display settings so that we'll be able to see the data types and sizes. So we're going to go to the Database tab, Display Options. We're going to go to the Table tab, and we're going to say Show Physical Data Types, and we're going to go to the Relationships tab and say Show Verb Phrases. Okay, we only need to see the forward ones. Set as default, click OK. Now, to make a column required, you simply just need to check that option. So, for example, the business rule states that it needs to see not only what positions each employee has held, but the start and end dates of those positions. So we're going to select the employee position entity, and under the start and end date we just check required, and that will remove the O for optionality. Now, for data types and sizes, we'll just do one entity so you'll get an idea how this works. I've selected the employee entity, and we're going to change the data type to the employee number to a counter number, since it's going to be automatically generated by the computer. So we're going to click the arrow. We type in the letter C. That'll bring us all the data types that start with a C, and we'll go down to counter. There are no sizes for a counter data type. Alright, last name, we want to change that to text since this is going to be an access database. If we type a T, that will take us to the text entry. And if we double click that 10, we can change the size of that to 30. So what I'm going to do for the next few minutes is just change these data types and sizes. The zip code data type, even though it's numbers, is not used in a calculation, so it should be text. Okay. The wage rate is actually currency. It represents money, so we're going to make that the currency data type. The Social Security number, even though it's a number, it represents, it's not going to be used in a calculation, so it should be text. Okay, that gives you an idea of how to do that. Now, because these relationships really do show action between the entities, there is something called a verb phrase, and that is the text that you see above these lines, or in this case, running through the lines. And it should always be a verb. So in this case, it's department has employees. That makes sense. We don't need to change that. Employees has a position, or we could say employees are assigned to positions. So if we click the line and we go to name, we can say employees are assigned to, and that will reflect that. Positions has employee positions. We could say positions, so that's fine. Has is a good verb for that. Okay. The last thing we need to do We now need to set the referential integrity to make sure that this department number column in the employee table matches a department number that's in this department table. That's a relationship issue, so we need to select the relationship line, and we're going to go under referential action, and we're going to say on parent update cascade. And what that means is if we change the department number in the department table, let's say it was 123 and we change it to 321, what that does is any record in the employee table that used to have that department number 123 will now be changed to 321. And we're going to set on parent delete cascade, and what this means, it will warn us if we try to delete a record from the department table that has matching records over the employee table. It will still let us do it, and it will delete everything, but it won't let us delete it without deleting everything. So we'll have to decide whether we want to leave it in there or delete everything. Adding the text box to put in the business rules is very simple. It works just like adding a text box would in a word processor. We're going to go back to the Home tab. Right now we've been using the pointer tool. In order to add in a text box, we just need to use the text tool. So we're going to click on the text tool, drag on a text box, and then just begin to enter in the text that you want in that box. You can use the enter key inside of the box. Now if you want some text to be right aligned and some to be left, you have this paragraph area where you can do that. So I'm going to select this text because I'd like to have this text, rather than being aligned center, to be aligned left, and it allows you to do that. Once you finish adding in all your text, you have a couple of ways to get back to the pointer tool. The easiest is just to click the pointer tool. Once you're back to the pointer tool, you can move this around, you can size it. You cannot do this while the text tool is on. I'm going to go ahead and save this. The last thing that I want to show you is that there are going to be times when you need to move this whole diagram together and keep all of the entities and the relationships together. There are two ways to do that. You could hold down the Shift key and select every shape and every line, which I don't recommend that because that's tedious. The other method is to use the lasso method, which means to put a border around all of the shapes and move them. So for example, if we wanted to move this diagram over to the right a little bit so there's a little more white space over here, we would select all of the Now, I did that deliberately. This one's not selected. How do you know? That blue line is not around it. Okay? So, here's how it would look if they all were selected. Now they're all selected. Once they're all selected, then you can use the four arrows to just move it up or down or across. And everything is moving together, and then you unselect it. Hopefully you have enjoyed this tutorial and have fun working on the actual diagram.